Hi viewers, welcome to the channel. In this video, we are going to explain about the nuclear power plant, how the electrical energy is generated from the nuclear plants, how it is generated. We are clearly seen in this particular video. In the backside, in the background of this video, I am going to play the how the nuclear energy is electrical energy is getting from the nuclear atom. Okay, shall we start the video? Let's get into the video. Okay, let us get into the video. So here in this particular video, I am going to explain you how the nuclear energy is created, covering half of the, so in general, in particular areas of the foreign, 50% of the electrical energy is getting from this nuclear energy power plants, large extent like a conventional thermal power plant. So this is a reactor, steam turbine, and also alternator. Turbine is connected to the alternator, and then finally alternate means either is supply and is transmitted to the electrical energy. So this is the reactor. What now you see, what you seen in the video, this represents the reactor. So what is the reactor? The only difference is that heat which converts water into steam. From this reactor, an enormous amount of heat is produced. That enormous amount of heat converts the that means this reactor is immersed. All these nuclear reactor components are immersed in a water. While it is immersed in a water, then what happens? The heat produced, which transfers the heat from that reactor rods to the water, and it converted that thing into the steam, and then steam is sent to the turbine, and the turbine will run the alternator. Let's see the video. Get into the video. See here, this is a nuclear fission. What is this nuclear fission? Produced by nuclear, not by burning the coal, neutron, natural gas, or biomass. What is this here? The uranium is used as a fuel. That uranium is bombarded with the neutrons. While doing this process, a large amount of heat is produced. That is known as nuclear fission. Okay. See, these are nuclear power plants of Doyle to use fuel as uranium oxide, U2. Thorium is also used. See, the uranium is compressed into a fuel pellets like this, and it is sealed here. These type of pallets combinedly connected to a frame and then immersed in the water, thick 20 centimeter thick steel reactor vessel. We call it a reactor vessel. So here the neutrons which is produced inside that will come and bombard with the uranium. So what happens? This process is known as nuclear fission. What is showing in the video? This is known as nuclear fission. That particular uranium element bombarded with the neutrons. If you see here once again I play this video. Nuclear fission comes and bombarded with the uranium. Then what happened? An enormous amount of heat is produced. If you see in that like this, when this process happens, this is controlled by a manually. That means in the outside the station, nuclear power station. So what happened? Water reactor vessel. So when these are called as control rods, when this control rods is immersed, then the entire process will be stopped. Okay. At the same time, the chain reaction is stopped. A nuclear power plant with a pressurized water reactor, high pressure reactor. What is this high pressure reactor? See, this is the primary circuit. So what happens here? The entire heat is transferred to the heat exchanger. So the temperature at the time of this process is 360, I think so, 320 degrees. Temperature is 320 degrees. When this pressure regulator sends the heat, this pressure regulator sends the high pressure reactor, send the hot water passes via the primary circuit to a heat exchanger or steam generator. This is the steam generator. What happens? It generates the steam. So this heat water travels like this, and the steam generator sends the steam like this. What is happening here? It will send the steam like this, and then the steam is always flow into the turbine. Let's show here. So it is a turbine. So what has happened? This turbine starts running. While the steam comes and hits the turbine blades, it starts running, and this is the shaft which is connected to the alternator. I will show you alternator. We all know that alternator is a AC generator, so this alternator shaft is also starts running. So finally, what happened here? Transformer is connected to a transformer, and then it given to a supply. And like this, the three-phase supply is created in this nuclear power plant. So again show the simple layout here. Again see here in this particular diagram what's happening here is, so the heat is transferred to the steam generator by using a pressure regulator. So this steam generator generates the steam and sends to the turbine. So the turbine, when the steam comes and hits the turbine blade starts running, and the turbine blade start, the shaft is connected to the alternator. The alternator is also running. What is the alternator? We know the alternator is a AC generators. From that AC electrical energy is generated. So due to this turbine shaft which is coupled with each other, alternator and turbine shaft, when the turbine runs, alternator is also run. Due to this action, what happened? The three-phase AC supply is generated and which is transferred to this. And what happened? The remaining turbine from the turbine, the steam is again collected. When the steam gets cooled, it is again converted into water, and that water is again sent to the steam generator, and again it starts sending the steam like this. Is we call it as a condenser. So what about here from this outlet? We just sent this to the cooling towers. We just sent the steam to the cooling towers, and what happened? The cooling towers cools the steam, and then again some water is getting from that. Some water is going to the outlet like this. So this is known as the cooling towers. So the water is putting to the cooling towers, and it will again converted into water, and it will be outlet, and again the water should be collected through the condenser and to the steam generator and to the heat. So this entire process runs continuously, and then the electrical energy is generated from the nuclear power plant. So by using the fuel uranium or thorium, we are going to get the electrical energy from the nuclear power station. This is all about the process how a nuclear atom, by using a nuclear atom, how we are just generated the electrical energy. Okay, thanks for watching. Thank you.